So for my photo narrative, I chose two pictures, and the pictures I chose, they're both hands-on activities and creations that the classroom has made as they develop their scientific learning and education. And I saw the most growth in terms of the students' learning curve and their abilities to exercise background knowledge, which is anything they know from outside the classroom, either from home or just being outside, and then what they know, what they absorbed in class, so what they learned in science lessons or reading books and watching videos, and then using both of those in their given assignments to help them. And it was the easiest to assess their learning and performance through direct observation. This being through practicum is where I got to see and witness their thought process to create a plan. So for the first one, I'll get into more detail later on, but they essentially designed a scientific invention and then drew it out on paper. And then in the same way, they also had to plan in their minds how to work together collaboratively to carry out moving the soil. And they also both use the environment as resources to build creations in different ways. So the first one, the invention, is what they used, the resources they used to recycle material. They made a device or an apparatus, and then the other, they use literally dirt, so an actual resource to help grow plants. And these were intended to encourage the class to understand that they can, each and individually as a student, play an integral role in advancing their ideas, any scientific idea that they could create, and then making a difference using their scientific skills and knowledge. So when considering the way people learn new information, Vygotsky recognizes the importance of tools. And among these tools, he mentions language. He emphasizes that the most, and this can be both physical and through the use of either symbols or language, where individuals can share ideas to discuss a concept together. Languages and symbols are the way in which adults transmit knowledge to children. So as teachers, this is how we teach kids, through languages and symbols, and then children then take those ideas and then build upon them. So this starts with us as teachers introducing different scientific topics. So in my read aloud during practicum, we read Here Come the Humpbacks, which is actually about animals, but it also talked about waste in the ocean, which helped us lead into our next activity, and it served sort of as a segue. So everyone sat around the carpet, and as we were reading the book, we noticed there was a page where they talked about some waste, and the students actually, they kind of brought up that they would find things at the beach. Some of the examples that they talked about were plastic bottles, tissues, paper cups, and like food plates, etc., all these things. So that kind of sparked discussion about what we were about to talk about further on. And then in our STEM project, we asked what they could do with this, with the waste that they found. And then before we read about, we also read scholastic articles about surfboards. And in that article, they talked about how they made surfboards out of recycled mass. So we asked them, like, what other items would you buy in the store today? And then what can you make with those reusable materials? So this was like a great idea for us to use. So Vygotsky also talks about the zone of proximal development, and it's often described as the space between what an individual can accomplish on their own or what they can do with the assistance of others, either a peer, a teacher, or parent. And what teachers can do to exercise this, ZPD, Zone of Proximal Development, is a process called scaffolding. And so this is when a teacher structures an activity such that a student is able to work within the zone of proximal development, and they can better reach the intended learning goal. So we challenged them to create an invention that could grab a kite that was stuck in a tree, and this included physical tools, like in this case just a piece of paper and a pencil to help the child meet their learning goals. So we went from the discussion to doing an activity, which was a natural transition to help us take the ideas and knowledge that they were excited to share with the class when they did talk about what they found at the beach in terms of ocean waste, and then implement this into their work. So they now had an outlet to demonstrate their skills, and then it also helped them to be super creative, which always keeps the students engaged, of course. And so I chose this picture of the students' work because it was a product of a lesson that we taught, me and my practicum partner, and together we used instructional strategies to deliver this course material, which was talking about the ocean, the waste of that, and then recycling that, and in ways that can keep students engaged and practicing their different skills and in creative ways. And this student did exactly what we asked him to do in the picture, which he created a kite grabber from recycled soda bottles, and he connected it with a stick, which is something that you can always find outside. And this was great because none of this invention that he created, hypothetical, it was no new material that he used. It was all reduced waste. And this essentially helps in problem solving in science. And it was also great that this student went back and referenced content that we had discussed in class. So besides that, learning in informal environments, this is another way that's really great to learn science outside of the classroom. And one of the best ways, in my opinion personally, is everyday learning activities, because this is just it's just natural, where you don't have to really force anything. It just requires things that you already know. So hobbies, discussion, entertainment, and sometimes even chores that people can engage with in a scientific way. And it doesn't necessitate any designated curriculum or lesson plan to follow, but instead, it actually naturally instigates conversation and curiosity in relation to science. So some examples can include like when children just run around outside and they find crazy observations when they're playing with dirt, what they find in worms and bugs. And then also this could include purposeful choices, like depending on what kinds of books they want to read or TV programs they want to tune into. A lot of it relies on experiential learning, and it's also very spontaneous. So it's just kind of very fluid in the way this kind of technique is learning. It caters to students' preferences, whether they want to listen to a podcast, like this podcast, read a magazine article, or watch a video about any science topic. It just offers them to be comfortable and open to learning science, since there's a lot less pressure and there's more freedom for them to explore topics that they want to delve into, and in the way that they want to. so they can learn about what interests them, what doesn't interest them, and what method of learning is best suited for them, because every child learns in different ways, and they're either visual learners or they're more auditory resources help them more. It varies for every child. And then teachers can ask children like what they learned from this, what they gained from this, and then this can help us learn more about students' emerging scientific understandings created as a result of this informal learning. And it can seem distracting because because they like to go off topic and responding to each and every child and their comments. They like to contribute, but it really develops this discussion where they talk about their own scientific interests, which is just great because it forces them to kind of talk about a topic that would otherwise, if in a very formal environment, which I realize is just not as productive and conducive to the learning environment at times. Obviously, this varies depending on the students and the teachers. But for the most part, I feel like, from what I've seen at least, it's had better results. And but like this also provides mechanisms for children to use their everyday learning experiences to help them better understand the scientific world at large. So overall, what they can see outside the world, and science content at school, just in general. And so the garden activity at Lawrenceville was a great type of informal learning experience, which I also enjoyed. And the picture of the students, it shows some of the students basically getting their hands in the dirt, and I really thought it was cool to see how engaged everyone was, and they were so passionate to be involved in the school garden, because it was really exciting for them to just like get out of the school building first of all, and just kind of kids are very visceral learners, and they have a lot of energy. They just like to do things in person, like to run around, hence why recess is really fun. So instead of just kind of being outside and just playing, it's kind of like they're playing in a science field where they can actually be quote unquote like almost like scientists in a way. And so here they were transferring soil from a barrel into a garden bed so that they could plant new plants that had withered and turned into weeds over the pandemic due to a lack of care, and because no one was there. And then in a different garden bed, there were students that were digging up kind of the dirt and the mud because there were a lot of weeds. And actually when they were going through the dirt and getting their hands all dirty, they found there was a really long worm, and they were all so excited to see it. Everyone gathered, all the students, to observe it, and they were all enthusiastic about really getting it back home, which I thought was really sweet. So just, you never know what you can, even if you have an objective going into these informal learning experiences, there's always something unpredictable in the way. And that's kind of the beauty of it too, because if you go into something thinking about, oh, we're just going to learn about plants, but then, oh, there's a worm like in the dirt, then it's just like you can also learn about other things like animals that come into play, how they play a part in the environment, in the dirt, and what kind of other bugs might do harm to the soil, what can help the soil. It just raises a lot of different discussion and forces kids to kind of expand on their knowledge that they already have, And then so they had to also move different barrels with the dirt, and also physical activity really increases engagement because they're actively involved in each task and they have to be focused on completing their duty. And it was also the most involved I'd ever seen the kids, where they also learned a lot simply through firsthand experience, which is also great. It was a nice break from being stuck inside to get out and explore the outdoors. They could appreciate nature, but learn about the limitless elements of the environment to be discovered. So, just a final recap, reflection of what I learned through the design and invention experiment and the gardening day. I came to understand the importance of incorporating instructional strategies and techniques to increase scientific achievement. Open-ended assignments with limited instruction seems a little scary, but it really kind of gets students to formulate their own ideas from what they learned in class. It exercises critical thinking skills, and then they can also observe and then ask a lot of questions about this. And so for informal learning, it provides opportunities for authentic science engagement inside and outside the classroom. They really get to touch, smell, and kind of experiment with whatever materials they have. In this case, it was the dirt. And teaching science is not a simple effort. I realized that can be adopted like only through a step-by-step manual or one particular way, which is kind of like a previous misconception that I had about teaching science, that you just had to kind of read all these books and like come up with lesson plans based on that. But no, there are so many diverse ways to strengthen science learning through tools, language, vocabulary, resources. And the most important thing, however, is understanding what your students' needs are in science, what they kind of lack, and then learning what helps them flourish. So what methods they really kind of thrive in to help them learn even more science, and to then model these lessons or activities to meet those needs. So the goal is really for students to be able to make connections between informal and formal science, and then backing it up with reasoning and evidence. So kind of how we read about the ocean and the waste, and then what they saw at the beach, and then using all that knowledge, applying it outside the classroom. So this heightened sense of awareness allows them to think towards problem solving and engage in actually doing science-related activities. So just as much it is a constant growing and learning process for students, it is also that for teachers as well, and we need to actively learn science to teach science. So we need to be learning more material, the best that we can do to expand and maximize their experiences, and then kind of also learning the students what they need to be able to be successful in science is really important, is what I learned. So overall, I think really being able to be in the classroom and kind of engaging with students one-on-one in person was a great way for me to kind of gauge this. And the STEM advocacy project, the read alouds, just kind of being outside and directing the students, but also letting them kind of be on their own and be creative, was a really cool way to further my understanding of teaching science.